with Mrs. Wayment. We're going to be taking a look at division and trying to work towards becoming more proficient. We want to get the right answers and we want to solve our problems in quick, easy, efficient ways. Let's take a look at our first problem. Our first problem is Mrs. Wayment had 10 pennies. She told Sam and James that they could have them. How many pennies will each boy get? This is one of the most easy ways to do a division problem because it's exactly what you did when you were a little kid. Think back when you were little. If you would have walked into the kitchen and seen 4 cookies sitting on the counter and you said, "Mom, can we eat these?" and your mom said, "You can eat them if you share them with your sister," you would have quickly said, "One for you, one for her, one for you, one for her," and you would have realized everybody got 2 cookies. That's equal sharing. It makes sense, and you've been doing it since you were a little tiny kid. Now, when you do it with a number like 10 pennies and you're dividing them up between 2 kids, you're just going to go through and say, "Okay, let's give," oh, sorry, my pen's not working. I have a ton of trouble with this pen, guys. Okay, you say, "Okay, this is Sam's, this is James. This is Sam's, this is James." And you're just going to keep going, giving these pennies to them until everybody gets the same amount. Okay, so Sam, James, and then once you find out how many once you've given them all out, you're going to go back and count and you're going to say, "Okay, Sam has 1, 2, 3, 4, 5. James has 1, 2, 3, 4, 5. Just like the cookies, but a little bit larger number. Let's go a lot larger now. When you do equal sharing, you can do it with any number, but if you're passing things out one by one, it becomes a very slow method to solving a division problem. So at the school carnival, at the end of the school carnival, there were 258 unclaimed prizes. Mr. Johnson decided to split the prizes up evenly between all 4 of the 5th grade classes. How many will each class get? Will there be any extras? So, blast that pen. Sorry, guys. Let's put our class right here. This will be Wayment. This will be Johnson, Sant, and we'll make this one Wilson. So you're going to give out all 258 prizes. If you give them out by ones, you're going to be saying 1, 1, 2, 3, 4, 5, 6, 7, 8. It's going to take you a long time to count up to 258. So we want to find a quicker way to do it. I know I could give out 50 to each of them, and that would have given out 200. So I'm going to start there. I'm going to give 50 to us, 50 to Miss Johnson, 50 to Miss Sant, and 50 to Miss Wilson. I've given out 200 of those. So I'm going to just drop this down to 58. That's all I have left to still give out. I need to think of what I can give out here. I'm going to give out tens. Tens are a number that are easy for me to multiply. So I know if I give out 4 tens, I'm giving out 40, which means that I now have 18 left. I need to think of a way to give out those 18. So I'm going to try to think of something times 4 because I've got 4 classes. I know 4 times 4 is 16. So I'm going to put a 4 in each of these. Now once I put that 4 in each of those, I've used up another 16. There's 2 left. I can't give out 2 prizes to 4 classes, so I'm going to leave these 2 as my remainder. It's going to be my remainder of 2. Mr. Johnson can take them home and give them to his kids. Now how many did each class get? Each class got 50, then each class got 10, and each class got 4. So each class gets 64 prizes, and there will be a remainder of 2. Well, let's move up to something a little bit more difficult. So this is partial quotients. I really like partial quotients because I like to pick my own numbers. And that's what makes partial quotients different from the US standard algorithm. In partial quotients, you pick your friendly numbers. So this is the same problem. At the end of the school carnival, there were 258 unclaimed prizes. Oh dear. I hate that blasted pin, guys. Sorry. There's 258 unclaimed prizes. We're going to divide those between all 4 classes. So what you're going to be doing is you're going to be saying, what can I multiply times 4 that gets me to 258 or less? Remember, you can use any friendly number. I'm going to go ahead and do 25 because I know 25 times 4 is 100. So I'm going to put my 25 over here. 25 times 4 is 100. I'm going to subtract that. So I'm going to have 158 left. I could easily do another 25. That would give me another 100. Subtract that. I have 58. Now, I know I can do 4 times 10. 10's a pretty friendly number for me. So that's going to be 40. Subtract it. I still have 18 more to go. Oh, now I'm at my 4 times 4 is 16. And that leaves me with a remainder of 2. Now all I have to do is go through and add up this little list right here, and that will tell me how many times I divided 4 into 258. How many 4s did I have in 258? So 25 and 25 is 50, 64. 64, and this is my remainder of 2. Now when you do partial quotients, you just come right up here and write your answer up here. 64 with a remainder of 2. Okay? The thing that's great about partial quotients is you pick your friendly numbers. Let's try it again with something a little more difficult. Kalena brought a huge container of bubble gum to share with the class. The package said there were 2,100. Sorry guys, as soon as I try to fix that pen, I made a mistake. Let's start that one over. The package said there were 2,145 pieces of gum. We have 25 students in our class, so we need to divide that by 25. With partial quotients, you get to pick friendly things. Something that's really friendly for me are tens and hundreds. Now, I know that it cannot be 100 because 25 times 100 would be 2,500. That's bigger than 2,145. So it's going to have to be something smaller than 100 and something I can multiply by easy. You know what? I'm just going to go with 10 because I can do that pretty easy. So minus 250 is going to be 5. You guys check my math as I go. 895. Oh, I forgot my 1. 1,895. If I keep going by tens, that's going to take me a long time. You know what, though? 10 and 10 is 20. So if I multiply 250 was 10, that's what I'm going to do. I'm going to do 20 because I know I just need to double 250. 250 and 250 is 500. That'll be faster for me. Okay. Oh, plus it was easy to subtract. I'm going to do another 500. I like that one. I did not mean to write that. Okay. Oh, that's going to be it. Oh, that's just going to be 13. Sorry. Let's just leave that. 13 minus 5. Going to be 8. Oh, I'm at 895. I'm going to do another 20. Subtract another 500. Man, I hate it when this happens. When I run out of paper and I'm still going. That happens in partial quotients. I just bring it up here, put that last number there, and just keep my line going. So I've used 10, 20, 20, 20. I'm at 395. I can't use another 20 because that's would be larger. So I'm going to go back to my tens. I'm going to put a 10 in here. I'm going to subtract 250. Oh, I'm getting close now. I can't subtract another 10, but I could do 5. That would be 125. Oh, look at that. Have a remainder of 20. 25 cannot go into 20, so I know that's my remainder. Now all I have to do is add up all these numbers on the side. 20, 20, and 20 is 60, plus 10 more is 70, 85. 85 with a remainder of 2. Let's go back and see if we got that same answer last time. Oh, I forgot. It won't let you go back and see it. Sorry about that, guys. Okay, let's try another one. This time we're going to use the US standard algorithm. With the standard algorithm, you don't get to pick your numbers. There are specific numbers that you only have one choice. This is what you must use. That's why partial quotients can be easier, is because you pick your friendly numbers. The standard algorithm, no. You have to use a certain one. So we're going to start with an easy one, and then we'll go back to our hard one. So Brooklyn helped her mom make cookies for a bake sale. They made 326 cookies. Get my pen back. 326 cookies. Oh, sorry about that. I'm flipping everywhere and goofing this up. They made 326 cookies. I'm sorry that you guys get all my mistakes. They're going to package them into bags of 4 for the sale. We're trying to figure out how many bags they'll need. So we're going to do 4 in each bag. So in the standard algorithm, you're going to say, how many times does 4 go into 3? What the standard algorithm is doing, I mean, that 3, we all know that's really 300. But what it's doing is it's breaking numbers down into small chunks. If you are thinking about place value, you'll be thinking, okay, that's 300. If you're not thinking about the place value, you're simply thinking 4 into 3, you're thinking that doesn't work. That's what the algorithm is for. It's to break it down so it's something small, so you're just able to do the easiest part. So 4 can't go into 3, so some of you like to put a 0 up here. I'm going to leave that out because I don't like to write zeros in front of my numbers. I'm just going to slip right over here to the tens. I'm going to say, how many times does 4 go into 32? That's pretty easy for me. That's a known fact. 4 times 8 is 32. So I subtract 32 and I get 0. But I still have the 6 ones. So I'm going to bring this down, and you don't have to do the arrow. And now I just have how many times does 4 go into 6? It goes 1 time. 1 times 4 is 4. So you're going to subtract that, and you end up with 2. So your answer is 81 with a remainder of 2. The standard algorithm, you have to pick certain numbers, the only numbers that will work with it. So that's where it gets a little trickier, is you need to remember what you're doing is you're finding the exact number, okay? Let's try one more. Let's go back to Kalena. Kalena brought that huge container of bubble gum. We're going to do it in the standard algorithm now. So we have 25 kids. Sorry guys, I'm really messing up today. I promise you someday I'm going to be good at this. 25 kids. We're going to divide up 2,145 pieces of gum. So we're looking at this, 25. Can 25 go into 2? No. Some of you put the 0, some of us leave it off. Can 25 go into 21? No. So some of you might have put a 0 there, some of you might just leave it off. Now we're all the way to 25 into 214. That can happen, and you have to know how many it is. This is where the standard algorithm gets tricky. You have to know how many 25s can fit in 214. I'm thinking of quarters, so I'm already thinking it's 8. That was pretty easy for me. Sometimes it's not, though. So 8 25s is 200. I'm going to subtract 200 from 214. It's going to leave you with 14. 25 can't go into 14, so we're going to bring this 5 down. And we're going to say, how many times does 25 go into 145? Because I did the number 25, it's a little bit easier than it is sometimes. I know 4 of them go in for make 100. So 5 of them would make 125. So I'm going to put 5. And that's 125. Going to subtract it. and I get 20 for my remainder because 25 cannot go into 20. So I have a remainder of 20, 85 with the remainder of 20. Now, all three of these ways work. What I want you to do is I want you on the homework to pick which way will work easiest for you, and I'm going to give you 5 problems to solve. You do not have to solve in all these ways. Solve in the ways that are easiest for you. And bring this back to class tomorrow. And if you have any questions or there's anything you're having a hard time with, bring those questions tomorrow too. There's one more thing I want to bring up before I let you guys go with this one, and that is how the partial quotients looks like repeated subtraction. Okay, so Mackenzie and I talked about this on Thursday. Mackenzie was saying I can do, get my pen back. Mackenzie was saying that she could do this, 2145, and she's going to subtract 25, and she's going to get 2120, subtract 25. It's going to take a long time to keep subtracting 25s. That's where partial quotients makes you faster because you can subtract in bigger chunks. Remember with partial quotients, when I did this, okay, instead of subtracting by 1, that's what this is doing, subtracting 125. You can say, okay, I can do 10, and that's 250. Or you can say, hey, I can do 20, that's 500. So partial quotients is really using the same great trick Mackenzie's doing where she's subtracting a 25 every single time, but it's making it quicker because you can subtract in chunks. That's enough about division, guys. Do your 5 problems on your homework, bring any questions to class, and I'll see you tomorrow.